System integration unit. This is just some overall, sometimes it's called glue logic of miscellaneous things, and it touches system-wide pieces, in particular pads, or pins. Same thing. We have, if you want to say it's the old 10 pounds of potatoes in a 2-pound sack, and we have 2 pounds of pins but 10 pounds of signals. So we're going to have to first of all assign a signal to a pin, and we're going to show how to do that. And these pins can also be just dumb output. So one of the first things you want to do is light an LED, for example, wiggle a pin. So we're going to cover how to do that here. So we have pad control for all these different pins, and multiplexing, because we can have different signals. We can choose one to be an input or an output. Ports that we have for the GPIO, when we want to talk to pins, we can talk to pins individually, like read an input or set an output, or as a group, as a port, and mask certain ones as well. In addition, the SIU can control inputs that go to the interrupt controller. Certain pins can be used to cause an interrupt. Every pad has a pad configuration register for the outputs. And then for you to assign an input, you will also need to configure these other additional registers, the pad select multiplex inputs, or PSMI registers. So let's take a look at them. The pad configuration register, shown here, has control fields, some for stepper motor and analog, but let's look at the diagram here. We have different input signals that can go to an output. One could be just general purpose, like a flip-flop output. Then we could be perhaps from the EMIOS, a PWM. We could have a different EMIOS signal coming out. It could be a CAN transmit output. So we have to assign one of these inputs in a field in this pad configuration register called PA, for pad assignment. That's one of the first very basic tasks we have to do. Also, if a pin is an output, we must set the output buffer enable. And if we want, we have an open drain option. So you can have your own external pull-up. You can do a wired OR if you want as well. Now for inputs, though, we have an input buffer we must enable for inputs. And we have the option on inputs to have either a weak pull-up enabled for the input, and we can select, is it a pull-up or pull-down? So it's a weak pull-up or down resistor that we enable, and then we specify which one we want. And then the inputs will go to a multiplexer, and maybe this is a CAN receive input. And we'll see in a minute that the CAN receive input, you'll have several choices, several pads or pins it could come from. So we're showing one here, here's another one, etc. There could be more. So we have to specify where is that input coming from. So this is just a cutout from one of our reference manuals, and it is in the signals chapter, and it shows the ports here. And I'm going to just break and go to the Bolero reference manual. If you look in your materials, you'll see our reference manual, and this is not in your slide presentation. But the reference manual starts chapter 1, an overview. That's a nice introduction. I recommend you read the overview. It will tell you more about the peripherals that we aren't covering. And chapter 2 has the signals, and that's where we start to look at the functional ports. So let me just zoom in a little bit here, and you can see we have a pin that we start with, and these are all, the P is for ports, so this is port A, bit 0, port A, bit 1, and pin 2, and pin 3. And these are the actual pinouts, depending on whether you have a 100 pin or up to 228 balls, package. Now, The register to configure the pin is shown here. It's just a number. GPIO, for example, would be, or the pad configuration for port 0 or port A, pin 0 is pad configuration 0. And if I want it to be a GPIO pin, then I will assign it alternate function 0. If I want it to be from the EMIOS and output, then it is alternate function 1, etc. And these are just binary values of 0, 1, 2, and 3 that we're going to load into that field. And as I go into other ports, you can see, let's scroll down. Here I start port B, and now this is PCR 16. And this can be a LIN pin, or from the EMIOS, or a CAN pin, or it could be GPIO. What's key is this is called GPIO 16. And this number 16 is the same as a pad configuration register 16. So every digital input can be used as just a dumb I/O, either input or output. And it'll have a GPIO number, and that number will be the same as that pin's pad configuration register to specify that it is GPIO or whatever signal it is. Okay, so that's where this came from in the manual. So we can see the pad assignment in the pad configuration register. We have a 0, 1, 2, or 3 in this case, corresponding to those outputs that we want. Now for input functions, we must set this input buffer enable to 1, and then we are going to use a different register to select where that input will be used for a particular peripheral. For example, here's a CAN 1 receive pin or input. So this could come from GPIO 35, as we call it, or PCR 35. These are the actual, PCR numbers, but you'd have to look up and see what port pin it is. So these are all different port pins, 35, 43, 95, and we have to specify in the field for the pad select, which one will be selected for the CAN 1 receive input. Same thing for CAN 2, CAN 3, etc. Let's say we just want to use it for a dumb input or output. We can use it as a single bit, single pin, or on a port basis. And to use it on an individual basis, first of all, we assign it as a GPIO function, and so that will have a value of 0. That's our pad assignment there. And then we turn on the output buffer enable. So we set that to 1. Now the pin will drive it high or low according to the value in that port pin's general purpose I/O data output register. So registers generally reset to 0. So initially this would be a 0, and then I'll assign it to 1 here, and when I execute this instruction it will go high. So this is how I will drive it high or low. Turns out this port E4 is connected on the evaluation board to one of the LEDs. So we'll do this later when we hook up the boards. We'll make sure you can turn this pin on just with a debugger. We're going to do the same thing here in the code that we're with the debugger, just banging the registers in the register window. Now for ports, we can have access for read of 32, 16, or 8 bits, and for writing as 32, 16, or 8 bits if they're not masked. We have a mask capability to support accesses, so we can write to certain pins, give it a value, but just mask out certain ones, so some pins are affected and some aren't.